Okay, welcome everybody. Today is May 30th, Robot Builders Night Virtual. We're fresh off of Memorial Day weekend. We're going to do the usual go around the table, talk about robot-y related things mainly. We have a queue started up already. Doug D, and then Harold has a question or two. Pat has a minor update on something, and Doug has a minor update on something, and then we have open mic. So Doug D, feel free to lead us on. Although you have to unmute since we muted you.
There I am. As you know, I've been working on my steampunk robot, and this is it. The box, the robot inside. And I've been making quite a bit of progress with putting things in it. Sorry for the movement. This is my L298N. I've got a spot there for the one for these motors, then a spot here that's going to be for the ones for the back motors. And I'm busy doing my wire control stuff. I've got these little things I got at Container Store for wire management, and they're doing really good about routing these wires. I'm pretty happy with them. You just peel off some tape and stick them on there, and then the wires go in there. I've got too many wires in these, so they're probably, I might need an extra one. But these motors, of course, will be running these pulleys that raise and lower the wheels, and then I'll have motors off the wheels here that do the actual movement. This is my hard to see what I'm looking at here. This is my battery holder with the on-off switch. I made this out of the whatever they call that plastic. And there's some more wire management on the back. And so I'm planning on having two batteries so that, pointing off screen here, two batteries so that I can pull one while the other one keeps things alive. This is the power distribution board where I've got my hand on the hot thing, the ground is on the other side, and the 5.2 for the Raspberry Pi is in the middle. And that'll be going on the edge of this. And, whoa, got loose wires everywhere. Plus, look at the clutter. This here sits down in here pretty easily. And if I didn't have the L298N in there, it would slip right down in there, and the batteries will sit here, and this will all close. The wires are going to come out the top, and the Arduino is going to be right here. I hope I'm on screen. Yeah. The Arduino will be right here. The Pi will be right there. And then there'll be a neck coming out of here with the head. So all in all, it's coming together. I'm getting a lot of wiring and a lot of things done. And hopefully by next week, I'll have these motors going down here so that I can actually test raising and lowering the legs. These gear motors here are not as powerful as the ones I got for the legs, but I think they run faster. You never know. I may switch out because speed may be relevant. Right now, I'm in the middle of wiring up the L298N, and the wires are those really thin pieces of copper wire, and I'm just heated up the soldering iron there. I'm going to tin them so that they'll go into there easier without spreading. And I may actually tin the wires that are on the switch on the back too. They keep popping out. I don't want anything vibrating out. And I thought, well, if I solder them down and they pop out, I'll be able to throw that switch away or do something. I've got a number of those switches. So, enough said. If anybody's got any questions.
Do you have to get on the plane with that?
I'm going to be excited when I actually get some motors running again. I tested my motor wiring stuff. I have not tested any PID control loops. Oops, I didn't mean to say that out loud. But I'm not going to wire up the interrupts right away. I'm just going to test, can they go forward and backwards, and then I'll work on the interrupts. Because I've never done that sort of programming before. I've just done skid steering and timed power. But the PID stuff, there I said it again, is a known technology with lots of examples. And I'm sure if I have trouble, y'all will give me a help with it.
Yeah.
So do you have to get on a plane with that, or?
No, I just have to drive down to
that's
Galveston.
Oh, you can drive. That's probably better.
Yeah, its original, or its premier purpose will be to go around the Steampunk Festival, riding the streets in Galveston. But then, after it's done with that, it'll be my harp robot running around my house.
Mm-hmm.
You probably don't remember when I first came in, I was thinking about, well, I'm going to build this robot that roams around the house and takes video and gets kicked over by the assailants, but at least it sends the video first. So that's its real purpose in the end. And it also, it's going to have all the telepresence possibilities that I put into Roby back there, because I'm going to be using the real VNC to be able to move it remotely, just like it was a telepresence robot. And
when is the show in Galveston?
Galveston is December, but there's actually a Renaissance Festival in November that we may do a dress rehearsal at. My wife and I has two other couples that are going together on doing this steampunk thing, so we may all go together down to the Renaissance Festival, the biggest Renaissance Festival in Texas, supposedly, and they sell a lot of steampunk stuff, so that'll be our last chance to buy goodies before we have to go show off.
Is that the one above Houston? It's like 3 miles out.
Right.
I've been there before. Yeah, that's neat.
It's supposed to be huge.
TRF, Texas Ren Fest. If you go to Scarborough at all, you'll see some of the same folks down there, because they kind of go around and hang around. They got their own, much like we have our nerd club going on here, they have their nerd club going on there. And you'll see a lot of the same people. And of course, you'll see people you won't normally see. But yeah, it's a lot of fun. It's a lot of fun, that place is.
Yeah, we may not want to talk about nerd clubs out loud, because we had a lot of fun doing Dickens, dressing up in costumes, and now we're going to have a lot of fun doing steampunk. And we actually went to Scarborough Fair and said, the next logical step is to do a lot of fun dressing up in Renaissance festivals. You never know.
Yeah. It's about, if I remember right, it's like 2 months plus that they have down there.
Mm-hmm.
And they have different themes for every weekend.
Right.
Type thing. So, yeah.
Well, when I'm saying nerd stuff, every now and then you'll get somebody being extra creative. And what'll happen is they'll all come dressed as Star Trek characters, because they do the time travel thing.
Yeah.
And, and do that whole bit about, we can't affect the timeline and things. And
yeah. Well, that would be the steampunk people too. They're 1890 stuff in this.
Yeah.
And the Renaissance is generally like 13, 14, 1500s. But
is that when they had dragons?
Do you want to dress up?
I don't remember them having dragons. See, they had lots of dragons there. And so, anyway.
That was high school.
Oh, it was high school.
Dungeons and Dragons.
Hey, Doug, have you ever used these ferrules? You might find these useful in all that wiring that you're doing.
Now what?
Ferrule.
Yes, those are wonderful. I love those things.
Yeah, I see little things in your hand, but I don't know what they are.
Let's see.
It looks like the Matrix. Red pill or
Can you see?
pill?
Can you see this?
Or yellow pill.
Think of it as okay.
It wraps around, or it sticks.
No, it's a probably. I'm going to just call it metal tube.
Okay.
Okay, and then it has a little insulator on the back. And what you do is you stick your wire into the insulator end, and it keeps stray strands of wire from shorting out. And then you have a crimper, looks like this.
Yeah.
And when you do it, you put it in there and you got your wire, and it crimps it down, and it's great for when you have terminal blocks.
That's what I've got here. It might be better than just tinning them.
It puts.
It's definitely better than pinning.
You don't want to tin them in this case, because then you can't crimp them correctly, and it makes a really nice finished look on your wire, and then you get to trim the ends of them just right so that your whole end will go into your terminal block, and you won't have any separation there, and it makes a really nice finished look when you get done with those things.
So could you spell that?
And you can get Amazon for $20. You can get you a kit that has the crimpers.
Here's what it looks like when you
It's
get finished.
FERRULE.
FERRULE.
L-E.
And I say
And,
$20. You get you a decent
You can
crimper.
get kits of them on Amazon.
And
You know, there is an
Probably
initial outlay of cash because you're buying a crimper and a bunch of Pharaohs.
Yeah.
Oh, yeah, I see them now.
You know, it's like a lifetime supply.
it's a lifetime.
You know,
It's a one-time
once you have
lifetime
them,
job.
you can use them for everything. And
I'll probably have the orders
they're
submitted before
definitely
we're done.
much more reliable.
Yeah, reliable and shake resistance, what I'm looking for here. Because there's going to be some serious vibration in this hound. So I'll probably have them ordered before we're done today.
Somebody might argue with me about this, but you don't even need the crimper at the outset because it's nice when you need to insert them and remove them again. But the screw terminals will do the job of crimping in the direction that you care about. In fact, it'll get re-crimped by the screw terminal every time you use one of them. It's just that if you then remove it, then it's possible it could come off. Whereas if it's crimped properly, that's very unlikely.
Graham, I'm not going to argue with you. I'm going to agree with you. It's just that once I got my crimpers, it's such a better experience.
Yeah. All right.
Yeah,
Cool.
and there is.
You want to use it?
Yeah, and Doug, there is a little bit of a controversy. There's two basic forms of crimpers.
Yeah.
There's a 6-sided crimper and a 4-sided crimper.
Oh, now you went and done it, Doug. Now you got
There you go.
Okay,
Six-sided.
I accept full
well,
responsibility.
okay, like I say, there's, you know, a lot of people argue for the 4-sided crimper because they say that it's more secure. Because I first bought a 6-sided crimper when I first saw it because I said that it looks like you'd want them to be roundish, you know. What did I know? But so I'm just saying either one of them will work great. So, but I'm going to say some people like 6-sided, some people like 4. The most compelling arguments that I've heard, I think the 4 is slightly better. Okay, but I have no testing. I've used both and they both work, you know. So
I think it might have something to do with how your terminal blocks, because some of the terminal blocks have a square side so you get a better mating finish, and some of them are rounded so the 6 side will get a better finish on them. But you know,
yeah,
I
think most,
looking thing, and then there's the
that one right there with the black handle. That's the kind of crimper you want for these things.
Yeah.
That's probably a lifetime supply. At least
look at this lifetime supply.
At least in the larger things, because some of those go up to 10 or 12 gauge, and I'm not, that's a 7 gauge AWG from 28 down to 7.
You might want to find one that's more slanted towards the smaller size.
You want the smaller, because I don't know about you, but I can't tell you the last time that I had to crimp a 7 gauge wire.
Yeah, I agree with you.
Yeah, so I will definitely do that, and as long as I have control of the window, if I can get past this.
Oh, yours.
Well, we don't get any other food, so we eat that.
But your sharing thing is covering the prompt.
Yeah.
Ah.
Well, that wasn't very useful. Well, I got one here that's a little more useful.
I'm going to hopefully stop presenting and turn back over. I just thought I'd give a live demonstration of trying to ask that question.
Yeah. I think I might have an answer for Pat on that one.
Okay. Well, I'm going to release my chair and turn the floor over to you, or whoever's in queue.
Yeah, whoever's in queue.
Next, we had Harold with a question or two.
First of all, the question is, putting this in the chat. Is there anybody's? That's the YouTube video that came across. So I say everybody's, all the people I've been hanging around with the last week and a half about Micro Mouse and their championships that are going on. So, who do we have anybody in the club that knows about this stuff?
The base, yeah. I don't know if we've had many people compete, but yeah. Kareem, you have something you want to say about it? I was just going to say that the algorithm is pretty easily known. It's the build. They're so fast now that the design of the robot is usually the key. The actual software algorithm, everybody seems to know what it is.
So I've got I say a bunch. I've got several people that have asked me when we're building one. And my thought was, if I could find somebody that would throw out a kit for the Micro Mouse and find a very small thing, if, maybe we throw this together as a little bit of a competition or not, do I think I'm competing with the people that are going to Japan? No. I think we're well away from that. However, the ideas and some of the things they got going on there, the video's really a great video. I put it in your to watch list, and I say nothing better to do because it is a great video. When you have a moment, go check it out, especially with how they're designing the algorithms of finding the maze. Because what happens is these things, the maze is not known until just as it's unveiled at contest time, and you're not allowed to update your robot after the maze is revealed. And the top two finishers, which I show in this video, finished within 20 milliseconds of each other. Mm-hmm. It's insane, man. They even got reverse ducted fans so they would suck the air out from underneath the robot to suck it down so it has more downforce to make corners. So they've gone crazy. So 50 years ago, they thought they figured this out and said, we know all there is to know about this thing. And they're still figuring out things today to make things go faster. Now, do I think I want to compete? No, I think it'd be fun to build one of these things and have it running around and give it a try or whatever, and do some stuff. I think that'd be fun. Or if we could find some place where I've been doing some, not necessarily kid stuff, but I've been doing some stuff. We're trying to get people interested in STEM. If we could find a kit that was reasonable that we could put together in the morning and test them out in the afternoon and that kind of stuff, I might be willing to invest some time and effort into that kind of thing. But I wanted to know anybody in the club has done this, because if I can't, the thing is, if I can't find support for doing it, then there's only so much of me, and that's not going to go very far. You know how that works.
Then you need a maze too, right?
And how do we build a maze? And a couple of people have already helped me with that a little bit. Get a big pegboard, paint it with the blackboard paint, and then in the pegboard we make our walls that fit into the pegboards, and come up with a little thing, and we can 3D print those things and change the maze on the fly with some parameters and things, right?
That sounds good.
Yeah, it sounds kind of cool, right?
Yeah.
And then you can, the algorithm is well known, but you got a whole bunch. I say a whole bunch. There's this. It's a complicated thing, right?
Yeah, it's so. Yeah, like I said, the actual robot build seems to be that's the key. You're probably
right. But do I think I'm going to do something? No. I mean, I would like to start very simply if we're going to start, and then we'll ramp the thing up to something crazy. I suspect at one time we had a Micro Mouse team around here in Dallas, but I suspect that was a long time ago, and those people all look like everybody else I'm looking at on the screen right now. Lots of gray hairs or no hairs. And
you might. I want to say there was. Harold, you were right. There was a group that did that here, and I don't think it was just Dallas. I think it was the Metroplex.
Yeah.
And there might be one down in Austin or Houston, but that definitely would be worth a search.
Yeah.
This, what this, I think this one would be a good one for is, maybe as an activity where everybody got together on a Saturday, in the beginning of the morning, and what do they call them? I can't, where you all work on a problem for one day and
hackathons.
This might be an interesting hackathon project for the club. But right now, I don't have the bandwidth. I can tell you.
This is a background task. This is not a foreground task. I'm asking here so I get more of a feel of the internal knowledge we have, because it's an IEEE thing. There's tons and tons and tons of rules and restrictions and all this kind of stuff. But much like we have the shoe wedge in our indoor robot thing that's going on in the wrong way Ray, fixing that as we go. I figure we do about the same sort of thing. No offense, Ray. No offense. Actually, anytime you say no offense, you're about to offend somebody. But that's a whole other. But you know how we do that thing, and we're a little lax on the rules, but we're here to have a good time and learn a little bit as we go. And I just thought this one might be interesting and garner some more interest in having the micro mouse day build or something. I'm still looking. I found some micro mouse kits that are nowhere near micro mouse as what they are now. And but I can't find. There's one outfit out of the UK that says it has them, but they're kind of big and they're about 100 pounds.
No.
When I say 100 pounds,
Yeah, you mean money?
Money. I mean money.
Yeah.
Which was
I would say that it's not a background task to be successful at it.
I think you're right.
I think that we've had people who, I remember people in DPRG going all the way back to doing the firefighting contests and things like that, which was also a maze following thing. And the only difference there is it had to extinguish a flame in the center. And so there's been like interest in people following MicroMouse all the way through that I've been aware of DPRG, but I've never seen any member mount a serious effort to get to the competitive level, and to do anything at all competitive is completely different from doing something entry level. But it's not a good entry level challenge in my opinion, because the infrastructure that you got to set up is significant. Maintaining a physical maze that's significantly large enough and adaptable enough, whereas we have enough problems dealing with a pre-printed line following course, right? If we can't do line following at scale as a way to get, if you're talking about getting kids interested, we used to do line following in schools all the time, and it works. It's great. It's a great portion of the curriculum. So you can definitely get that accomplished, and you can accomplish that with a wide variety of different kinds of robots, right?
Yeah. So were they doing the challenge line following course though? Something that?
No, they were not doing that. No, absolutely not. That's not an entry level thing, is it? Right.
Yep.
But there are the two stages up to that are things that certainly the first stage is something that you can definitely do. Back all the way down to middle school, and arguably as low as I would say 4th grade, to get kids just starting to, and you can do it with a single sensor. Like you don't even need a bar sensor, right? With multiple.
Yeah, pretty much. Pretty much, if you're not on the line, get back on the line. Got it. Yeah. So, just the infrastructure you got to manage in dealing with contests, you got to put up and take down on a daily or a weekly basis. That's like a huge portion of getting it right. MicroMouse with the actual vertical walls.
To stay upright,
and the rigidity and it's like that's a lot of work, and it's not apparent from the videos. Although I would say that Derek did a great job on describing the evolution of MicroMouse through the years. It was a really well done video.
Yeah. Well, when I say background, here's the deal with that. Is background as collating information to decide whether we want to do anything or not, as opposed to actually doing something. Because it's doing something that's going to take effort, and it's going to take a lot of it.
I see. Gotcha. Yeah.
I'm different phases of stuff. I've got a lot of stuff that I background and collate. In fact, I'm about to show you a couple here in a second, right? So I've got, as I say show you, I don't have a good way. I'm being lazy, and so I don't have a good way to show you at the moment. However, what I do have is I found a YouTube channel, and I've got several videos that I'm going to put in the chat. I found this person to be very, very helpful and very, very easy explaining all kinds of stuff. I've not seen this channel before. I'm sorry, John. John K. I didn't mean to take away your spelunking into YouTube, because that's kind of your train. These happen to come across, and specifically this last one here.
Are you talking about like questions, what's the meaning of life, the universe, and everything, or what? No,
that's 42, man. That's 42.
42.
We got that. Yeah, we got that.
Different than that.
He's looking at meaning of life for robots.
So I put 3 links in here that are all going to the channel, but different ones. The very last one is involving our friend P, I, and D. And I have not gone through it again. It's 15 minutes, but after trying to do some of this stuff and figure out some of these things of what's going on, I found the combination of these videos. The last one being how do you do this PID control. They show you an example of spooling up a simple PID and going through some of the demonstrations and stuff that seems very straightforward to me, where I've been confused and a lot of other times. And the middle one I sent is involving how do you control if you've got 4 motors that all need to be PID controlled. How is a good way to go about handling that? And that's one of the questions I wanted to ask last week, but I was just too worn out, simply too worn out. So, and I looked at the coding things, and I learned a couple new coding things. One of them be a template. One's an atomic block, and the other one's a template. And I didn't know what a template function was until I watched this video. And it's really a cool thing, I think. And because that's one of the questions I had for Carl lingering on last time is, how do we track all 4 pins doing the thing? And how do you make those happen? And what's a good way? Because I can just start slamming boards on there. And I really don't want to go buy RoboClaws at $80 a piece for every pair of wheels. So I'd rather do something else. Ray's laughing at me because he knows how expensive they are, I guess. And I don't really want to do that. But so how's an effective way where I can do this, and then manage it? And these 3 videos gave me some thoughts, and I figured I wanted to share them with the crew.
Sounds good.
Can you even get one for $80? They've had price increases.
I actually saw them at one for $120, and then I saw some other ones that were about $80. The 7-amp ones.
Yeah. Maybe that one.
Yeah. and yeah, the bigger ones, no. And so I started looking at other motor controllers that were slightly affordable, and I think I can get some Polulu. Or there's a couple of different ones I was looking at. I'm still on a search because I'm going to need those eventually. Because I'm going to hope Jim bought out. I mean, Scott's not on there, is he? Because I figure when I beat Scott's time for Quick Trip by 5 seconds, I figure he's coming. He can't let that stand, right? And so Jimbot, that was all Jimbot had. So Jimbot's going to have to get hulked out a bit. And in order to make Jimbot better, we're going to throw some of those 37 millimeter motors on them. I've got a balance bar kit in here that's got a pretty beefy set of motors. And in that case, I'm going to need a little bit more juice and be able to run those encoders pretty well and figure out. I'm still figuring out how the optical flow stuff works. I started looking at it. I'm going to order 2 or 3 of those and play with them and see what happens. But I think I should be able to tell that if I get those working, but that's a whole bunch of ifs, and I've got this other thing Hugo bought with the Mecanum wheels that, is all his motor controllers is going to have for the moment. But that's another thing. But looking at hooking out Gymbot, I saw all these things. I'm like, wow, we took this little robot and we're about to redo it completely and, you know, literally put the gamma radiation to it before it's all said and done. I'm planning on having the black chassis still there and just start bolting things onto it, just so maybe I'll paint it green. I don't know, but that kind of stuff. I don't really know. But anyway, that's some of the things I was thinking about, and because I was trying to figure some of that stuff out. Somehow YouTube knew I needed to watch these videos. I'd never seen this channel in my life, and now these videos started showing up all over my stream after I watched one or two, and I thought they were pretty good in general in a lot of ways.
Sounds good.
Yeah.
Yeah,
So
sounds really good.
That's my deal. That's my deal on the whole thing.
Cool, thanks. Very good. So then we have Pat, and then Doug, and then open mic. So Pat, something about you still there? Yeah, you're with us.
Yeah, I'm with you.
Arducam, right?
Pardon me?
Arducam.
Arducam, exactly. So it's been a while since I worked on this. My program that I had created 3 zones is no longer working, and when I'm looking into it, it looks like they've changed some of their API on how to access the camera. So I've just basically loaded up the new software with the camera to test, and I just wanted to show you. I know we're having problems. I was having problems with the distances weren't being reported back in Python in the correct to match the image. So I just wanted to show that and see which way it's going here, so I can show you. Share. Can you guys see that? And so I'm going to start it up. Bring this guy back. Bring this guy into play. So you can see the picture there. I put 3 boxes in front of me on the screen, which I can't see right now, but maybe I'll move on.
Yellow, red, and
orange. So 3 different distances.
Yeah.
So if I go in the box on the right, it's telling me it's about 96 centimeters or 0.96 meters.
Meters, yeah.
Which is correct. I go to the middle box, the yellow, and it's telling me it's about 1.4 meters, and which is correct. And I go to the red box, and it's telling me it's about 0.64 meters, approximately a couple feet. And that's where it is. So it looks like they've lined this back up, and it's working in Python. So this is the example program that they give. I made no changes to this.
Mm-hmm.
And last time with the example program, I was having problems, and it wasn't working at all. So
If you go to the background, Pat, the blue and behind your boxes, what does that say?
That's the wall behind the boxes on my left, and that's 2.5 meters.
And is that realistic?
Yeah. It would be approximately 10 feet, and I would say we're fairly close. 3 meters would be 10 feet, but for all intents and purposes, I would say it's close enough at a far distance. There is some interference in there. You can see, I don't know if it's showing up light blue, dark blue.
Yeah.
And I believe it's looking at the farthest image it sees in that little bounding box.
Okay. So it looks like it can easily go to 3 meters, maybe?
In their documentation, it can go to 2 meters or 4 meters. And it comes, I don't know why they say 2 meters or 4 meters, and it comes with a cable. You can get the cable that's 2 meters or 4 meters. And I don't know, to move the camera that far away.
Okay. Yeah.
So, but I've got it's a 1 meter cable on there right now just for the camera itself.
Yeah.
I've got the power supply tied into the Raspberry Pi, which is why I'm getting a low voltage warning all the time. So that has to come out of there, but it's not even on the right robot right now. I've got it loaded on the wooden monster just to, it's easy to clamp to and raise the camera up high. Yeah.
Gotcha.
So, but it seems to be at least working up now when I'm pointing at a box. I'm seeing an approximate distance. I wish I brought a measuring tape with me, but I would double check that 2.5 meters to see if it's right.
So did they do a code revision or something, or an update?
I got no response from when I sent them the email about it not working. And I'm just thinking now that I'm remembering back to when I built this little addition I'm sitting in the house. I was thinking it was 12 wide, but it's not. It's 10 by 14, and my camera is almost a couple feet from the end wall. So that's probably pretty close at 2.5 meters to the blue spot on the wall. So far it looks good. Out of curiosity, I strung, and I don't see if I don't know if it shows up on the camera, a wire across.
Oh yeah, it is.
Yeah.
So showing up in the camera, and if I click on the wire, I'm not seeing it basically. The distance, it's not being detected. So I don't know if I'm going to detect the chain link fence with it. But I'm fairly confident that I can detect, brush, trees, whatever, with this looking forward to detect obstacles left, right, and center.
Pat, I haven't looked at this one in a long time, so I want to ask you: is a lot of the weightlifting being done on the actual camera unit, or is this being done in the Raspberry Pi?
It's being done in the Raspberry Pi.
Okay.
So the camera is putting out the distance buffer and the an amplitude buffer.
Gotcha.
So you can see the amplitude signal is there, and she bounces back. I'm assuming it's a distance based on the light. And then they merge the two pictures to come up with the colors. But it's all being done in essentially Python and OpenCV.
Okay.
So yeah, I think on the MaxPi, the A010, they actually map, the grayscale image to a colorized image. So they, from the 8-bit grayscale data, they do an RG and B, I think 1 byte each for each color. And so there's an array that I've seen, and some of them that start out with, the smallest number in the array is, dark blue, and it moves on up to the, through the spectrum. So,
yeah, I haven't looked to see how they're matching the colors, but it is essentially that you're going from a numpy array, which is a grayscale image in both cases, coming back out, and they convert the grayscale images with the amplitude and the depth buffer. They combine the two and create an RGB image and display the colors. So,
is it putting much load on the Raspberry Pi 3?
Well, let's check. So I'm running DNC into it right now, and it's about 40% loaded.
Yep.
So,
any idea what the setup's consuming as far as current?
Enough to give me low voltage warnings all the time. So they're saying up to 3.5 watts, I believe, is what they claim.
Oh, okay. 3.5 watts just for the camera?
For the camera. And I believe that's just a peak. Every once in a while, there's a peak out of the camera. and so I get like another pop-up warning.
Well,
that
they don't have any. They only have on the 3, don't they? Only have USB 2s.
well, this is on a Raspberry Pi 4. This one.
Oh, okay. This one, so you shouldn't be getting low voltage warnings on that.
On this guy, I'm feeding him out of a 10 amp 5-volt converter. Because he's not, it's on the Wooden Monster, and it's not the only thing that he's powering a Raspberry Pi. He's powering a hub, a USB hub. He's powering a couple other things. But the camera itself, I plugged into the Raspberry Pi board.
Yeah.
And I think I'm just drawing too much through the Raspberry Pi board bus. Coming out with 5
is this a 3 or a 4?
It's a 4.
Oh, okay. Because I want to say the 3s, you know, if you're a USB 2, you're only supposed to take a half an amp. So that would mean that if you're at 5 volts and you're at half amp, that's 2.5 watts right out of, that's the max you should be able to pull out of a USB 2 point.
Yeah.
And the 3s are supposed to be substantially larger. I can't remember the spec.
It's supposed to be, but I don't believe the Raspberry Pi can put out the full current on the USB 3s. Because I believe it's a couple amps on USB 3.
Yeah, you're right. I don't think it. Well,
2 or
I don't
2.1
know.
amps or something like that. But you'd be way over. You'd be exceeding what the Raspberry Pi is doing itself. And it's not the average current, I believe, that's giving you the problem. It's the peak current.
Somehow I did some testing. I'll have to look back. I did some testing on a 4 because I was wondering about, you know, whether or not my my Oak D-Lite would be causing it to fail. And it did work, but I did definitely saw, you know, the limitations of there. If you're not getting enough power, you can. The symptom is that the USB port will sag. The voltage will sag, and so that can get you in trouble. So, okay.
Any idea about a frame rate, Pat? Or
I haven't pulled it out. There is a way to get a frame rate out of it. I just haven't pulled it out. I'm using the default app.
Yep.
And you know, right now I'm looking at it going by, and I know I'm getting over 10 frames a second just looking at the numbers fly by, which is, you know, for if you're moving at let's say a foot per second or a little bit more, I think it's adequate. It's the reaction time and the motors and everything else that I think that's going to be more of a problem. So, anyways, I just wanted to give a little update on that. So it looks like the software has been updated and working. I worked quite a bit on this. I tried to load the lib camera drivers on Raspberry Pi Buster OS. And I worked at it, and I just couldn't get it to recognize the camera at all. So I had a problem with different versions of software being able to run on Bullseye versus Buster. And so I'm thinking about using the Raspberry Pi strictly to look at the video cameras and serve images to an Arduino and have the Arduino control everything. Basically, just serve distances out to the Arduino and report them as a left, right, and center distance on my zones.
does that one? It just looks like an external camera, right, to the Raspberry Pi. You don't plug it into the camera connector, do you?
It's plugged into the camera connector.
Oh, it is. Okay.
Yeah, it goes to the CSI connector.
Yeah.
I believe it's called. And like I say, right now I've powered the plus 5 volts in common off of the Raspberry Pi pins, which is why I'm drawing all that power through the USB connector, and that's why I'm getting it to drop out. So I just didn't want to be bothered up to wire another 5 volts when it's not going to stay on this robot. It's just going to move over.
Didn't one of those cameras have a split power connector? Was that
I think the OD light has a split power.
does it? Okay.
Yeah, well, it doesn't have a split. You could buy a split power connector to supply it with too.
Yeah.
But I found on my robot that I was using last fall, you didn't absolutely need it. Now I'm sure if you hung a whole bunch of stuff off your Pi, you might need it. But if it was just the OD light, it wasn't a problem.
So typically anything USB I'm running right now, I go through a powered hub. And so it's that's how I'm trying to get around with the sagging voltage. But like I said, I'm considering having all the motors controlled. The motors and the main robot loop controlled in an Arduino. And just running the cameras through the Pi, the high power stuff basically that's easier to run in a Raspberry Pi than it is to run on an Arduino.
I have to admit that kind of the configuration I use on my robots, I don't know a lot about it, of course, but I use the Pi for the motors and the sensor. Oh no, the Arduino for the motors and sensors, and then the Pi for the UI and the camera and the smarts.
Yeah, and that's what I'm using. I'm using it for the smarts as well, but I've ran into problems where I get a latency. So by the time the Arduino communicates, let's say I'm 1 cycle behind, so I'm reading whatever, if I'm doing 20 loops per second, 50 milliseconds later, I get the data into my Pi because I'm off by, a fraction of a few milliseconds, so I don't read it when I process my loop in the Pi.
Right.
And then I'll get it. So the next time I update everything and send a signal back out to the motors to stop, I'm at 100 milliseconds, so a tenth of a second. And so it all adds up a little wee bit.
Right.
So
even at the fastest serial speed, you're going to have a delay.
Yeah, so that's why I'm thinking about doing it in an Arduino, and I don't know if anybody else has had that problem with communicating over serial to a Raspberry Pi with delays. So I was looking at other things. So I was looking at using a Teensy. I was looking at using Arduino Mega or a Do. I have a Do here, Arduino Do, and trying to use the USB port to communicate with some of this stuff. But there is a maximum buffer. I think its maximum is 500 bytes. And plus, it only allows, I believe it's serial, or the second USB port. I believe it allow you to put a hub in there, but it'll only talk to mouse or keyboard type stuff. So it won't allow you to put 2 or 3 serial ports through a hub. So I'm still trying to figure that one out, how I'm going to do it. So for now, it's going to be testing with the Raspberry Pi and keep failing the way I've been failing all along.
It's got good distance reads now.
It's got good distance reads. So that's it's a bonus. I don't have to play around with this image. I just have to modify my code where I split the image into a left, a center, and a right zone. And then I look for the shortest distance in either of the zones and say, hey, you got an obstacle for now. And I wanted to test that out. So just like a 3 photocells or 3 ultrasonic sensors or something.
So how do you do that? Are you looking at a color or looking for a color, or you don't go through thousands of distances?
I just go through thousands of pixels. So basically, I horizontally split the image into 3. Vertically split it. So I've got a left, center stripe and a right stripe. And then I just go through and I blur the picture using a kernel, 5x5 kernel, so that it just sort of modularizes this picture. And then I look for the smallest distance I see.
Have you ever heard of cartoon mode on the Raspberry Pi cameras?
I have heard of cartoon Pi mode, but this one, the camera uses its own API. So it's not it's not strictly a video camera image.
Okay. Yeah, I was going to say, if you want to get it, like into set colors that are really one true color, cartoon mode is a really easy way to do that. So,
well,
but
yeah, so I may be able to zone it out into different distances and map it to colors.
Yeah.
So I haven't done much playing around with this one. I'm just surprised that the distances were working, so I figured I'd show that to everybody, and hopefully we'll test it. So I'm going to try to go capture some images with chain link fence and see if I can get some distances on it.
Since this is using the camera interface, have you tried it on a 3? Do you know what sort of, do you have to use a 4 is what I'm getting at?
No, as long as you can run Buster.
You have to run Buster.
Oh, sorry, Bullseye.
Bullseye,
yeah.
Okay.
So if you can run Bullseye, it comes with the lib camera drivers already, and you just jump through the hoops to install the ArduCam drivers.
Yeah, I'd like to see this on one of the newer Zeros. I don't think they call it 02 or whatever they call them.
The 02Ws.
Yeah.
I'd like to get my hands on one.
Yeah. Be interesting to know because that's, so much smaller.
Well, exactly. I try to do it without even having a preview image. Once I know it works, get rid of the preview images and just serve out the data.
Yeah.
So you don't even need to set it up with a desktop at that point. Just copy your files over and run it without.
Because I want to say the 02 is supposed to be like a 3.
Yeah.
Yep.
Yeah.
So I can try this on a 3. So I do have a spare 3 lying around.
Yeah. Okay.
So I guess they refer to it as pixel diddling. Are you looking at every pixel in a zone? And
I am. Well, the one I'm using is. Let me go find it.
yeah, they said it's one of the slowest things you can do, but in some cases there's not any other way to do it. So.
Well, OpenCV is pretty quick at what it does typically.
Oh yeah.
And it is. I can't see what I'm writing with a box in front of my screen. Topa, be quiet. So here's where I split the image. And it's a NumPy array. So all I do is average my last 10 readings with my count. And I look for, in the left split, non-zero images and try to find the minimum. Otherwise, I'll end up with nan, not a number.
Mm-hmm.
And I multiplied by 100 just to give me centimeters instead of floating point. And I do that for all the 3 arrays. left, center, right. And I get my, I'll get the location in the image. I get a row count and a column count. And then I use that to draw a circle in the array when it runs. But this is using the old commands out of the API, and I started working on correcting it. But I did some flipping of the images to try to correct it, and it just doesn't work. I don't know why my images, I couldn't size it, but so if I try that guy, I don't know if it's going to run. So it does run. Let's put this guy back up. Now you can see that the image is a lot more fuzzy on this one. And if I select it, so my selected rectangle distance is 176 centimeters, which is wrong. So since they've corrected that in their API, all my distances have been wrong as I'm trying to use this.
Okay. All right. I have to look that up.
So this one shows you the depth map that it returns, as well as there's the amplitude for the light being reflected. There's the depth map that it creates from that, and then there's the combined, the preview. So I've split this image, the preview image, in basically into three, or it's not the preview image I'm looking at, sorry. It's the depth map. I split into three horizontally, or vertical lines through it, and then I look at left, center, right for now. And then that's the data I'm getting back from it.
Okay, cool.
So just give you an idea of what I've been playing around with here a little bit.
Mm-hmm.
So that's it for me. Anyone got any questions or?
Looking cool.
Well, I'm sort of making a little bit of progress with it. Like I say, I don't like the fact that I've got to run the Raspberry Pi and like a Raspberry Pi 4 or a full-blown Raspberry Pi 3. And possibly I can offload some of this to a 2W, and that's got the same power as a Raspberry Pi 3, a lot more compact, and then just run it essentially without the desktop to try to speed things up as well.
Cool. All right. I think, Doug, you were next in line. Then we had an open mic.
Okay, I'm gonna let's see here. I just wanted to let everybody know that this is ending tonight. But if it's 23% off of all active status across the board. So everything they make, 23% off if it's not unrestricted or rationed. So just something that if you haven't seen the Polo Lou sale, I know that this should have gone on the list on Friday, but it didn't. So if anybody's interested, so what does that mean? That means that their encoder, their 37 millimeter encoder motors, which are the big ones, now cost $50. But if you get it on this sale, they're $40. So that's kind of type of range of things. So if you're looking at motors, if you're looking at any boards, this is a good time. Okay. Also, the second thing I wanted to say was there's a Micro Center has now got teensies on available. All right, so Pat, I did this. I said I live in Canada and I can't create a chat GPS account because it says my cell phone is a landline. And they said,
Move from Canada, right?
no, they said something about that if you reach out to them directly for assistance, you can support their support page and contact their customer support team to report the problem and seek a solution. So anyway, see, that's their suggestion of how to fix the problem. Okay.
I'll get back to you within a few months.
Oh, you think that they might be
Within a few months.
I had to try that last week, by the way. I was, for work, my computer was on the Wi-Fi to my local home network, and then I was plugging into these routers that, depending on the test configuration, I was cycling rapidly between. A hardwired connection to these routers, in some cases, I think was routing me through the UK. And at some point I happened to toggle my browser, which of course all the tabs are open, and the one was ChatGPT. So I went there to go ask it a question, and it came up and said, "You've been blocked. If you think you've reached this in error, you can contact here." And it went to some random help page. So I was ticked off. So later I went back, and after quite a bit of effort, I was able to, I think I had to start some kind of, like the help page, you have to wade through their standard. Of course, they have a chat bot for help, right? What else would they have?
Yeah.
But when that's useless, you can go and like engage. You can say, okay, I'd like to follow up with more. So then they open another chat bot with a form. So you enter in your details and they say, thank you for your submission. We'll try and get back with you within like 7 days or so. I don't think I've heard anything from them.
Well, so you're out
working the next morning. So,
and that's with an account, right? You already
that
have
was
an account.
before I paid. Then it started working the next morning. And, I did some Google searches because Google was still working, and some of, or Reddit, and some of those people were saying that sometimes when they see suspicious behavior, and I'm guessing in my case it was non-US IP addresses or something, then it'll temporarily block you and then re-enable. So I suspect that might have been what it was, because it just started to work the next morning, and then I promptly signed up for the paid level so I could really gripe about it if they started to do that nonsense again.
Okay, well, here was something I thought was kind of interesting. I'm not going to. This is really short, guys. Okay, so I asked this question. Write a C program for a Teensy 4.0 microcontroller board that data fuses output of a GPS, a 9-degree IMU, and odometry data from 2 quadrature encoders on a differential robot base. Use a Kalman filter to output filtered heading and X and Y location information. Okay, and it said, certainly. Anyway, so this is an interesting setup, but but it's, if you really think about it, it says, read the GPS, read the IMU, read the encoder, do a filter update. So I mean, it's not in itself very useful. Okay, I'm not saying it's wrong. But it's not very useful. So I said, include the Kalman filter library C code. And then it came out with this. And this was a little more useful. And I'm not saying, I really haven't pursued it beyond this point, but I thought, maybe. So Carl's thing, or maybe a Robo Columbus Chat GPT coded robot might be possible. We'll see how it goes. That's all I wanted to show. So where is it? Stop sharing. Stop sharing. Okay, I should stop.
Cool. That means we've got this week's Chat GPT fix.
Yeah, yeah. I'm just saying I'm just curious of if with a little luck, if you can extract more useful information, and
I think if you broke it down into smaller, discrete steps, it could help each step of the way.
Yeah.
But you ask for that many things at one time, and I don't think it's going to be likely to be successful.
Well, the thing was, I wanted to get the data fusion in, and I wanted the kind of the basic Kalman filter, routine.
Sure.
And I think I might have gotten that. Okay, I'm gonna just say I'll have to spend more time on it, but it would just be kind of interesting to see, because, like I say, there was two parts of this that I wanted. I wanted that data fusion, and I wanted to see if I could get all the fused data put together into a filter. So we'll see how it goes. So
I think I may have. I think I was sharing that. One of the things I was asking it to help with was so this goes back to the 6CAN.
Yeah.
And it was if you're like scanning, if you got the robot scanning around using visual input through OpenCV, how to like place the cans on the field, and then the next step was, well, if you keep scanning and you want to keep on updating it, and you're seeing cans that are coming into and out of camera, right? And I don't refresh me if I'm wrong, but I think I shared that with the group that I sort of.
Yeah. I remember seeing some.
Yeah. I was asking it to help with it, and the solutions at the time, I hadn't tested any of them, and the solutions were not testable in my environment because, it had normal loops in there and things like that, whereas we have to be non-blocking, and we're running with state machines, so there's a more complicated infrastructure to the whole thing. But I tested all of the individual suggestions that it came back with when especially with this was the GPT-4 suggestions, and we ended up implementing those, and they all worked once they were translated over to our platform, right? So it was and the code structure, apart from the fact that it was wrong for our infrastructure, once we adapted it, it was conceptually all right. And it works.
Yeah.
It works to the extent that the limiting factor in our case was the estimate to the distance of the cans, because we got a very good estimate of the angular orientation of the cans inside the view frame, and sort of chaining that back through the actual heading of the robot. That's very high accuracy. The thing that is lower accuracy is estimating the height, the distance to the can based purely on its height in pixels.
Yeah.
Right. And even the mechanism that is suggested for estimating that, it sort of suggested the right. This is sort of a proxy for proper lens calibration, I guess. Instead of calculating the actual intrinsics of the lens, we just measured the can at different distances under fairly consistent lighting considerations. And because the width of the can varies a lot more than the height of the can does, based on the angle of the light coming in and things like that, we decided to go based off just the height of the can, so that takes out one of the dimensions of it. So it's not necessarily the inverse square anymore, but it suggested the appropriate line fitting algorithm that we would probably have to go through, and the mechanism for like throwing that into a spreadsheet and deriving the actual fit. All of those things, they worked beautifully. And so the only limitation is that there's still some, based on the lighting situation, there's still some variation on the of the can height because the blob varies a little bit depending on how dialed in your blob is.
Yeah.
So once we're like beyond a certain distance, the height varies more, and so we're less sure about its distance, and so we need to sort of factor that. We haven't gotten to the point of actually calculating the uncertainty, but we need to incorporate that uncertainty into the idea of merging a previous can position with a current can position, right?
Yeah.
In other words, deduplicating them.
Yeah. That's cool.
So, but it's like all of its suggestions were right on.
Yeah.
They just had to be. They just won't work out of the box.
Right. Yeah. And well, that's what I'm saying is, obviously it doesn't. In the case of filtering, it doesn't know your variances. I mean, of your different, your different readings. So you've got to, you got to put that in.
Yeah, you got to do the tuning yourself.
Yeah, they put values in, but they're just kind of like off the wall values. So anyway, kind of cool. That's all I had, guys. So if you want to look at the Pololu site, you got until midnight. So take a look at it.
Shopping away.
Yeah.
Just to give you guys an update, I just measured out the distances reported back by the camera.
Yeah.
And roughly, just quick measurements, I'm within a couple centimeters of what it's saying.
Good. Good.
So which is, let's say approximately 3/4 of an inch.
Mm-hmm.
And we're not talking something that's 2 centimeters away from the robot. We're looking, to steer clear by a foot or whatever.
Yeah.
By 30 centimeters. So I think it would be adequate at this point.
Sounds good.
Can I show something?
Sure.
All right, open mic, you're on. What's up?
Okay. I have the this is the Cypede MaxSense A010, and this is like the mini-me to the thing that Pat just showed. So it's only got 100 by 100 resolution at the most.
Mm-hmm. Is it using USB? I mean, it's again another Raspberry Pi sensor.
No, it actually has a serial port, and you can run it up to 3 million baud, I guess. So, and you can reduce the. What am I seeing here? Oh, okay. Let's see. This is what I wanted to show. Okay, so that's kind of at arm's length. And just remember the camera always adds about 10 pounds, so. Anyway, so there's various things you can do with the comm tool. Like the units here, that should be 10, 10 millimeter divisions, and you can bring it all the way down to auto. Kind of picks its own scale, and I think one, you've got to get extremely close to it to be able to show up. So if you're looking for really fine resolution on something, I don't know what you'd look at that, find a crack in a wall or something. But I'm thinking most likely
maybe scanning, 3D scanning.
Maybe, yeah. But this is back to arm's length, set at 10 millimeters per. You can play with the bins. Right now, this is 100 by 100. You can do 50 by 50. So, a lot coarser, or 20 25 by 25. Where there, I truly do have a blockhead, so, you know.
Hey, Rick, can you put I didn't catch what sensor this is. Can you put a link of where you can get one of these?
Yeah.
How much does it cost? Do you know?
I think last time I looked it up, it was $26 or almost 27.
Yeah, the link I found shows $29.90 at Seed Studio. I put it
Okay,
in chat.
maybe that's what it was then.
Yeah. That's, yeah.
Anyway, so I'm going to put it back to 100 by 100 resolution. It draws a whole lot less current than the Arducam, and it does have a serial interface connection to it. I think it's supposed to go to like 2.5 meters is the max distance. So that would probably work, you know, on the 6-can soccer course, because that's about its length. I haven't played with the frame rate. You can also adjust the frame rate here. It's set at 15 now. You make it very slow, but I don't know why you'd want to make it that slow. Well, I guess to maybe reduce data. I thought it actually went, yeah, there's 20. So 20 isn't bad. I mean, that's what that's what my motor loop runs at.
Yeah.
So I could get could get one update per
50 milliseconds.
Yeah.
What are you changing that's making all of that noise pop into it?
The frame rate. I put it back up to 20. So yeah, I can just, show it at the wall. There's curtains and so it works pretty good. They do have, okay, I'm gonna put this down. Let's see. Oh yeah, you could connect this to. It looks like I got rid of it. Okay, I'm looking for MaxPi IDE. Yeah, there it is. Okay, they do give you I just referred to it as time of flight A101, or sorry, A010. Getting dyslexic here. Anyway, they actually can connect to serial pins 24 and 25 on the Max dock. That's what I have. Were you going to say something, Carl?
No, go ahead. I was interrupting you.
Oh, okay. Anyway, so they started out with the UART at 115.200. Okay, those definitions. This actually uses AT command, so everything is an AT command. So you're setting the baud to 5, which I think is actually the 921-600. They have at the highest resolution, it could be 10,000 readings. But it looks like I don't know if that's a limitation with with the UART or with the way this was set up. But the jet colors, this is where they actually colorize that image. So they're just using this as more or less a lookup to translate it. Anyway, so you can display it on, let's see if I have the one that shows that. System CPU. Yeah, this is where it's actually hooked up to the Max dock, sorry. They use an interface card between the two, and I didn't think I needed to. Not unless I'm missing something there. wait a minute. No, I think this is actually the LCD on this. I have mine in a case that's hinged, and I think they just flipped out the actual processor board.
Okay.
So I don't think it is actually another board. Come to think of it. Anyway, so they provided that code, and I haven't tried to run it yet, but it'd be nice if I could use the processor on the OpenMV H7, and because that uses Python and should be able to accept 100 by 100 image. I know you can hook up one of the thermal sensors that's God, I want to say it's like 64 by maybe 32. It's I don't have the part number on the tip of my tongue, but you can hook up different sensors to the OpenMV H7. It doesn't have to be a camera module or sensor. So that's what I was thinking of doing, and then letting it, do all the processing. Anyway, so that's all I had to show. I'm going to try to get out of all these things. Stop sharing. Okay. Anyway, so consumes a lot less power. I think it's going to be a little easier to hook up to a processor. If you can do it with a Kendrite A210, why not the ST's H7 series processors. Just as long as the serial port's fast enough, which I think it would be. But anyway,
Cool.
that's all I got.
Neat.
Oh, Carl, did you put the link in there? Oh, yeah, it looks like you did.
I don't know if I got the right one or not, but I did a quick search on the
looks like
image. Yeah. Cool.
Yeah, there is another one that's got much better resolution, but it's a lot more expensive than this one. But for what it does, the amount of power it consumes, it's got, that's the USB interface, that's the serial interface. They even provide you a little dongle to, plug into this connector. For $30, seemed like a pretty good deal.
Pretty wild.
Anyway.
Okay, guys. Well, that's cool. Thanks, Ray. We're definitely in the free form part of the meeting now. So, who else has something else to try and ask or share tonight?
I've got a question.
Excellent. What you got?
So this is an advisability question. One of the problems we always have is how to convert motion through a 90-degree angle, right? So the bevel gear is the standard approach for that. There are situations where bevel gears are rather pricey in terms of the kinds of at the kind of power level that we need, and you may still have extra need for planetary gears anyhow to get the kinds of reductions that we need, especially for things like arms. One thing that I saw happen this year is a number of teams started moving towards worm gear boxes for driving like the main shoulder on an arm. And I've always stayed away from those, almost not quite a policy, but very reticent to go to worm gears because there's very few worm gears that are back drivable. And what I worry about is situations where a student accidentally gets their hand or appendage caught in an arm that is now locked in that position, and you can't back it off because you've got a non-back drivable worm gear in the mix. Not all worm gears are self-locking, but it seems like most of them are. Just from the inherent design. So
Yeah.
I was just wondering if you guys had any feedback, advice, concerns. Am I overthinking this? There are lots of situations where a worm gear is going to be the most efficient way to translate power through 90 degrees and include a power reduction at the same time. Or speed reduction, torque increase, whatever.
Seems like you could do something like the friction clutch on it. You know what I'm saying? So the
on the outside,
joint can slide.
Sure.
So I haven't got any experience yet, but I'm planning on driving my robot with worm gear motors, and they go forwards and backwards. They do auto lock when not being in use. I'll keep you posted.
Yeah, most of them do. It has to do with that angle on the worm gear and the coefficient of friction, and it's very rare. In fact, I think a lot of people fall into the trap of assuming they're just never back drivable, and that's not exactly true. And I actually saw a paper where they were introducing vibrational friction into the gearbox through a separate motor, just for the purpose of lowering the static friction so that it was dynamic, so that it could be back drivable. So in a lot of papers around with robotics around people, like even some of the stuff that Rodney Brooks was doing, like most of the industrial robots are not necessarily back drivable, and that can produce dangerous situations when people are in close proximity to the robot.
Yeah, one of the things on a worm gear drive is that if the worm itself, instead of having a single tooth that goes all the way around, has multiple teeth, so that your reduction isn't n to 1, but 2n or n over 2 or n over 3, it is more back drivable. You follow what I'm saying?
I think so. Yeah, I hadn't thought about that. I don't see that in when I'm shopping. I don't see.
Well, that's not a common thing to do, but I'm just saying that I have seen where people have, instead of having a single threaded worm, it'll have dual or triple.
Yeah,
so that it is back drivable.
Interesting.
Yeah, it can have multiple starts on the worm, is I think what they refer to it as.
Sure.
Yeah, I think actually the lower the ratio, the more back drivable it is. If you have a really high reduction, the worm and the worm gear, the teeth are almost perpendicular.
Yeah, exactly.
Right.
Yeah.
That's the whole point of having the multiple spirals, is that you reduce the reduction so that it is back drivable. It's the fact that it is such a high reduction that makes it non-back drivable.
Well, you also often have even a 10 to 1, which I wouldn't characterize as a high reduction ratio necessarily, but they often won't be back drivable, and it has to do with particular how well the gears were finished or machined, and the materials involved, and what the lubrication's like. But I think I have seen some situations where that kind of ratio is back drivable in a single start. But it might be like high slip materials as opposed to typical high strength metals used in a higher strength gearbox. Anyhow, okay. Yeah, all of the ones where we've
Yeah,
had arms
there's,
that are strong enough to lift the robot itself, for example, and we've produced a number of those. We've always relied on just regular planetary gears for the initial reduction, and then, just regular spur gears for the final stage. But they end up being very, very large. They end up consuming an awful lot of space. And some of these worm drive gearboxes that are designed for like the NEMA 23 stepper motors, that they're pretty solid and reliable, and they look like good choices. It's just that I just worry about those dangerous situations. It's unlikely that a student would get into it, but I wouldn't know what to do if they did, right? Because exactly. And the thing is, if you're reliant on turning the motor to get out of that situation, last thing you want to do is accidentally turn it on in the wrong direction, so that it's exactly gonna cut that finger off.
Fascinating. That's something I never looked at before. And now there's another rabbit hole to go down into.
Yeah.
Thanks, Kareem. All right.
Sure.
Yeah, I think I guess they still use them in trucks, but probably not in front wheel drive cars anymore. You always had the third member, so it always had a pretty low reduction, from the drive shaft to the differential in the rear end. And those, typically they're at most a little over 4. You may have gotten like a 2.73 or something in the early 80s, but they were, those are definitely back drivable, but again, a really low ratio.
Well, those aren't worm gear. Those are, yeah.
They're
those are bevel
well,
gears.
that's true. They're bevel gears. Never mind. Not a worm gear. You're right.
It's very few bevel gears in the sort of power transmission strength and minimal size that we're interested in. There's just not a lot of them, and a lot of them are just like, we've tried using the 90-degree adapters for like screwdrivers, drill drivers, as a way to do that, and they tend to have just a lot of backlash, a lot of slop, and tend to skip pretty easily at the kind of power ratios we're asking for it. So.
Oh, yeah.
So when you talk about the ratios, is that literally the ratio of turns of the worm gear to the turns of the whatever gear it's attaching to?
It's less about. I think it's less about the driven gear and more about the worm and the angle that it creates, right? So if you think about how steeply angled that helical screw is, I'm trying to find it. There was some document I found at some point that mentioned certain angles that on the worm that at which point for most materials it stops being back drivable. And I remember being something like, actually, I don't remember. I can't find that document, so I'm sure I'll be able to search it a little bit more and find it again. But
yeah, I think most worms and worm gear, it's actually a line between the worm gear and the worm, and there's some other geometry where you can have multiple teeth in contact with it, and there's a company that kind of exploited that. want to say they call it cone drive, but it's been ages since I've looked at any of that. So it was a way of distributing, instead of the load being on one tooth, it was spread out across many teeth, and they may have referred to it as helical drive. I don't know. Oh, but the dithering thing, I've seen that on drives. You actually add little noise to the drive, and it's always, making the motor output. So it's basically buzzing or humming. And I thought they did that so that, it would keep, basically the gear train from like getting stuck in one position or something. So,
I mean, the one benefit of a self-locking worm drive is that if you do intentionally use it, then it'll hold up your load against gravity all day long without taxing your motor, right?
Mm-hmm.
So,
and that's what I think. I've looked at an auto lift that uses one of those to raise the car. So,
I think they still recommend you putting a brake on your motor so that it's also stopped on the input side. In other words, don't completely rely on the friction in the worm gear to stop it from back driving. But most high gear ratio worms will do that effectively, and especially in like the FTC case where you're trying to. Where just holding up a load on a long lever arm will like drain your battery in no time. It's a nice thing to have. Our robots have always had to continue pulling battery juice in order to keep their arms extended.
Interesting. Well, that's cool. Yeah. Thank you.
Thank you.
All right. So here we are. Any other topics? We see
I just found this thing about
in the background there. Oh, sorry. We see Dave Anderson walking around on his new bionic knees, so that's good.
Oh, Dave's on here?
Yeah. He's masquerading as unknown, I think, but.
Oh, okay.
Yeah,
I didn't know.
It's a Dave David Anderson.
Oh, sorry. I got the A's. Yeah. Double mix up. Up and about. Good to see that.
You got new knees?
It's not as good as I'd like, but depending upon how much I've done with it during the day, it depends upon how painful it is when I try to go to bed.
How long has it been?
Time. Yeah.
It's been almost a month.
Okay. Well, let me know how it goes. I'm thinking about joining the market for that myself.
Ooh. Ouch. Yeah,
well,
a friend of ours.
I've got a doctor that I've used that did mine, and he did it without cutting any tendons or any muscles. So
nice.
So
they do it laparoscopically then, so you don't have the huge Frankenstein scar on your knee.
Well, there's still a certain amount of material you got to take out.
Scar. I think I showed that the other day. So it's about 8 inches long.
Oh yeah. A friend of ours just had both knees done. I guess just on the outsides. I guess they can do the outsides and the insides, but she just had the outsides done. And she didn't say that she was going to have these, really long incisions. She has about a 1 foot incision on each knee on the front side of her knee. It's like, whoa.
Yep, that's about what you get.
Yep.
But interestingly enough, on mine, although it looks like, it's got stitches and what have you, all of the marks were the marks a lot where he drew the line down that says, okay, we'll cut it here, and then we'll put the pieces back together like this. Because there were no stitches at all.
Oh, wow. So did they use staples or anything else?
No, it was just,
Yeah.
it was apparently glued back together again, and it looked like it had a Scotch tape on the top.
Yeah.
The Scotch tape.
Oh, yeah. Yeah, they used
The
super
Scotch
glue.
tape was basically a bandage to protect it.
Pretty
Yeah.
cool.
Yeah, they used I think it's the same compound as
Super glue. Yeah.
super glue. Yeah.
Could well be.
Super glue is fantastic for paper cut.
Yes.
I understood it was developed by the military for exactly that purpose, field repairs of skin, which is why it works so well to glue skin
Was it
back
really?
together. Yeah.
Yeah, I'm supposed to go have a follow up with him next Monday, and I'll ask him how he glued it back together again or whatever.
He gave you the beauty scar. So,
No,
Yeah,
Frankenstein scar.
How
my
much
wife
time
had,
before they asked you to start putting weight on it again?
I
long
was
be-
walking.
Yeah.
I was walking the next day on it.
Wow. Amazing.
Now,
Yeah, my
the
wife
main-
was doing the same thing. Physical
Yeah,
therapy was the next day.
is to one of the things that happens is that much like when you have a broken arm or something like that, the tendons shrink up and you've got to do therapy to get it all back out again. The muscles do the same thing, and so that's what I'm in the process of doing, is doing therapy to be able to straighten the leg out completely.
Yeah, my wife had one of her knees done, and she found this. It's like I call it industrial aspirin. It's aspirin, Tylenol, caffeine, and she